My name's Lynn. The call is K5LYN. You can find me at K5LYN at ARRL.net. So if there's anything I talk about here that you want to hear more about, want to see a schematic, want more information about it, just send me an email, K5LYN at ARRL.net, and we'll get it. Okay, we've talked about the fact that I'm not an engineer. Actually, I was if I had any training at all, it might be when I was a Boy Scout and I learned the code, and then I built a crystal set back in the 1960s, and on my crystal set, I could hear the ham radio operators in my neighborhood. And that kind of got me to thinking, what about my grandmother's 1930s Stuart Warner? It had a shortwave band on it. Could I hear those guys on that? And sure enough, I could. So by the time 1963 came around and I was in high school, I got a novice license, had a DX40 and a Hallicrafter's S38, and I was living well in those days. I was a novice for 4 months, and then I got a general. On that S38, as I was telling Diane earlier, I could hear the people talking what the AMers called mushmouth. And they were guys in zero land, skipping in to North Texas Panhandle where I lived. And because the S38, of course, didn't have any automatic volume control, those guys from zero land were all about the same level. So I could tune them in on my S38 and as I got dressed and got ready to go to high school. And I thought, man, those guys, they sound good. And a lot of them turned out to be talking on Central Electronics 20As. And I said, when I grow up, I want one of those. But there was a lot involved in growing up, right? I had to get a master's degree in Latin American history from Texas Tech University. And I finished that up in 1970. And while all my peers were running off to Canada to escape the Vietnam War, I said, well, I'll go to South America and make the revolution. So I hitchhiked from Lubbock to Laredo, Texas. And then I got on the train and I started going south, and I didn't stop until I got to Bogota, Colombia. And I didn't make the revolution. I got a job teaching English at a language school there. And I had a Colombian girlfriend that I spent a lot of time with on the weekends. And I really spent about 2 years wandering around in South America, Colombia, Ecuador, Peru, Bolivia. But by the time I was 25, I thought maybe I really better grow up for real this time. So I went back to Texas and I got a job at the Austin State Hospital. The original name for that hospital was the Texas State Lunatic Asylum, and I thought, well, I'll fit into that pretty well. So I got a job working there, and I worked there for 25 years. I started out working on the wards. I had to go back to college and get some more education to fit into the Texas mental health system. And when my age and my years of service reached the number 80, that meant I could retire. And one of the first things I did was go out and buy a Central Electronics 20A. Okay? Let's skip ahead and take a look at what that station might have looked like back in those days. You had a Central Electronics 20A, powered by a VFO, excited by a VFO, and you had to zero beat to your companion receiver. And I thought, now wait a minute. We're talking the late mid-1990s by now, okay? Now I said, now if these Collins guys with a separate transmitter and receiver can transceive, and these Drake guys with a separate transmitter and receiver can transceive, why can't I do that with my 20A here somehow? So I learned from some guys that the Hallicrafter's SX115 had a VFO that on 75 meters operated on 5 megahertz. And that's the same excitation that we need to make a 20A talk on 80 meters, right? So I got out the frequency counters and I started looking at this, and I figured out that if I came off the VFO transformer in the SX115 with a cathode follower and an amplifier tube, that I could feed that into my 20A and I might be transceiving. So I began to put this together. That's a little mini box that plugs into the back of the 20A. It's powered by the 20A filament and plate voltage. Because, Bob and I are sort of fans of the Mosley CM1 receiver. And I thought, well, now if a 6AW8 does everything that the Mosley CM1 needed, maybe that's what I need to do for a triode and a pentode here. And so I made a cathode follower, and I took the signal out of that SX115, fed it into my 20A, and sure enough, it worked. It worked just fine. But they were a little bit off because the 9 megahertz crystals in a 20A may or may not be at 9 megahertz. They may be plus a little bit or less a little bit. That's basically the circuit that I got. If you look in your handbook 1962, there's a VFO circuit in there. I just whited out the oscillator tube, and that's the cathode follower and amplifier that I built into that mini box there, okay? Now there's one more problem here. You might, because just the same way you've got to get the BFO crystals on the Collins S line in both the transmitter and receiver on exactly the same frequency to transceive correctly, or on the Drake twins, you've got to get both those oscillators in the transmitter and receiver exactly right. You may have to adjust this transceive signal a little bit to make sure you're receiving and transmitting on exactly the same frequency. If you notice the lower right hand corner of the 20A there should be a hole where you feed the audio into it to adjust your sideband suppression and audio oscillator. I don't tune sideband suppression that way, so I made a variable capacitor right behind that hole and stuck the shaft through the existing hole and put a variable across the 9 megahertz crystal in the 20A to narrow down that zero beat to exactly dead on, okay? And once the circuitry warms up, it transceives without any drift or any problem for hours. It works really, really well. So what do you do to get 15 watts into an amplifier? If you put that into a 30L1, you get what? 150, 160 watts at best out of it. So I decided to build an amplifier here. There in the upper right-hand corner. If you look carefully, you will see that that looks a lot like what a Central Electronics 10B front panel looks like. If you fill all the holes you need with stuff like flashing lights and jacks and other things and decorate it up. I had a junker that was beyond salvation, so I borrowed that Central Electronics 10B and made a case there. And then, let's skip around here a little bit. We may have to find exactly, well, it's further down the road. The bottom line about this amplifier, okay, to grid drive a 6DQ5 like you find in the early single band Swans, if you put 4 6DQ5s in there, then you've got 4 times the output of a single band Swan, or the Swan 240. And you don't want it to oscillate, so you swamp the grids with about 500 ohms of carbon, but that's still not a real good match, so you put a Yaesu antenna tuner from the output of the 20A before the grids of that amplifier, and there you have a pretty good match. And I get 450 watts out of this on a peak reading meter. Somewhere we have a better picture of the insides of that, and maybe we'll come to it here in a little bit. But anyway, that was my first transceive project that actually transceives like the Drake twins or like the Collins S line. And I've called a net with it many times. Let's jump ahead here. I built a second transceive adapter because I wanted to transceive onto other bands and to work with the Drake R4B receivers, because there's a lot more Drake R4 series receivers out there than there are Hallicrafters SX115s, right? So what we have here is a prototype, not exactly a prototype, a work in progress of a Central Electronics 10A. You can see plugged into the back there a little bit bigger mini box. What we have here is a pentagrid converter tube with a crystal oscillator at 14.645. I did the math and figured out that if you heterodyne the output of the Drake receiver, what the Drake called an injection signal that they would use to transceive with their own receiver, if you heterodyne that against a 14.645 crystal, that will give you the 5 megahertz correct excitation for the 10A to transceive. This is kind of what it looked like when it was all in a trial and error mode. And how I got that circuit, in QST, I think it's April 1965, there was a circuit published whereby one might transceive with the Collins 75A4 and an HT32. So I used the same kind of configuration, but I said you don't need that many parts. You can use one less tube if you use, again, the 6AW8 combination crystal oscillator and pentode amplifier. So I built this circuit here and heterodyned it against this 14.645 crystal oscillator there. And sure enough, this is what it looks like once I had it all built. You got two 5 megahertz coils over there, slug tuned. The variable capacitor with the shaft, the long shaft, is how you do your final tuning to make sure you've got it exactly 0 beat. And the big resistor in the bottom drops the 400 volts out of the 20A down to about 175 or something like that I'm operating this whole circuitry with. Now this works really well and transceives with any Drake R4 series receiver and any of the Central Electronics early exciters. There's one flaw about this deal, is that it really takes a long warm-up time, because that oscillator, maybe somebody that's better at doing compensation could make it less drifty as it warms up. So maybe it takes about 2 or 3 hours for everything to absolutely settle down, because think how many oscillators you have going here. Not only in the receiver and the crystal oscillator and the transmitter, and then I add another one here. It transceives beautifully, but you have to let it warm up 2 or 3 hours before you're not correcting it from time to time to make sure your transceive is exactly dead on 0 beat. Okay, let's move on. There's the picture of the amplifier interior that I was looking for a while ago. This is the 46DQ5 amplifier. The tank coil is hand wound on a plug-in coil form. The typical broadcast variable capacitor with, I don't know what the tuning capacitor came out of, who knows. But I've got 900 volts on the plates of the 6DQ5s, and I came up with about 200 volts on the screen, which is really right out of the Swan manual for the 240 Swan. And I'll say something about how I came up with the screen voltage, because it's kind of unusual, and I've done this 3 times. The typical way to come up with screen voltage on those kind of things was a dropping resistor off the plate supply and a voltage regulator tube or something like that to stabilize your screen voltage. And I said, well, I've got to compensate for pretty radical current shifts on the plates of these 4 6DQ5s here with audio. So maybe I should just stay away from that secondary plate voltage winding. And I have a bunch of transformers hanging off the power supply. That's the power supply for that amplifier, okay? And the reason I've got a bunch of little transformers, in fact, there's 2 you can't even see. There's 2 around the back there. If you engineers, give me a break here. If you take a 5-volt filament transformer and you connect the 5 volts to the 6.3 filament volt winding, you come out with 160 volts or something like that on the other side on the primary winding of the 5-volt transformer, right? And then you bridge rectify that and filter it right, you really get about 190 volts of very stable screen voltage, because it doesn't swing with the plate voltage. Not at all. It has nothing to do with that. And I've done that on this amplifier and the 2 amplifiers that I'll get to in a minute. It works fairly well. Okay, here's the 2 transceive stations, the 20A here on the left and the 10A on the right. And right above the Drake receiver, you see what looks like an old Night Kit Novice transmitter. It was when I got it for $5 at an estate sale. But the 10A puts out maybe 7 watts, something like that. What are you going to do with 7 watts? Well, I said I'll turn this 807 in this novice transmitter into another little amplifier. Same kind of thing, swamped grid. And the only thing I did wrong, well, I had big ideas. I took the 807 out and I put a sweep tube in there. But the folly in my thinking was, if you don't put a better power supply to that sweep tube, it's not going to put out much more than the 807, okay? Even though I solid stated the power supply and so on, it actually came up quite a bit, and I get about 40 watts now of single sideband out of that, what used to be novice transmitter, and that drives the Drake L4B. And I'm getting about the same, about 400 watts out of that deal. So it's working pretty well. And this is all push to talk, everything works. If my recording works here in a minute, you'll hear these stations. Let's jump ahead. Maybe several of you know KG7TR Mike is maybe the world-class leader of homebrew equipment. And what you see right here is a cheap and easy SSB from QST 1956. And he built it for 20 meters. But with 20 meters this dead, I said, Mike, can you and I get together, and I'm going to take that off your hands and convert it to 80 meters. And so he and I, back and forth by way of email, converted this cheap and easy SSB with his expertise applied way beyond anything I would ever know how to do. But he walked me through making it an 80-meter version. I paired it up with the Drake 2B, and the two looked like they were made for each other. And that all runs into another Collins 30L1. Now, I got even stranger here. With all these oscillators that we had, especially on my 10A conversion, I began to think, well, maybe I wouldn't have stability problems if I didn't have so many oscillators going all the time that had to straighten out as they warmed up. What if we get back to the idea of generating the single sideband signal at the operating frequency? How can I find an ultra-stable VFO, something like the SB10, which was built for the Heathkit Apache? Never had before in its life. I came across this Collins 310V, a Collins vacuum tube PTO, okay, from 1948. I recapped it, and I said, what if I make that the VFO for this Heathkit SB10? And the Collins 310V, it's a 2E26, and it can put out about 30 watts. That's way too many watts to put into the Heathkit sideband adapter. So I said, why don't I just put a potentiometer on the screen of that 2E26 and lower that output down to exactly what the SB10 wants. And I have it figured out right now to give it 2 or 3 watts of excitation. Well, you got 10 watts coming out of an SB10, right? That's not going to do anything for the 30L1 here either. You see that DX60 back there? This is the third small grid-driven amplifier that I made here. I did 2 things to the DX60 to make it an amplifier. I converted it to AB1 in the usual way, as many people did for their SB10s, by the way. Same thing about the filament, same thing about the screen voltage. But instead of the power supply, back behind that DX60 that you don't see there is a Drake series TR4, R4 series transmitter power supply. And that now powers what was a 6146. I needed a 12 volt filament now with the Drake supply, so that's a 6883 plugged in there. And so now that's a pretty big talking DX60, about 50 watts coming out of it now, of single sideband. And that 50 watts goes into the 30L1, and I'm again back at 400, 450. Actually, sometimes I can get about 500 watts out of that deal. And you can't see you can see the Drake 2A receiver that I have powered up with it there right now. Okay. The point that I'm trying to make here, I'm no engineer, right? I'm a social worker. But you can find stuff around cheap and use a little creativity and put it together. But can you really do something with this, like call a net? I mean, is it something you could do like you would do with a modern radio? Let's just stop right here and see if I can make any of this stuff work that we have plugged in. I've got to make a pop here as I plug this in. One more. Hold your heads. And let's see if any of this works now. Okay, I think we've got about 30 seconds here. We have a net, boat anchors net, on 80 meters, and I'm one of 4 net controls. And it's recorded by W5MIX in the Texas Hill Country. And he recorded our net, and I went back to try to find my stuff on it.
This is K5LYN. My name's Lynn. I'm in Austin, and this is the Boat Anchors Unlimited net. Been getting together here on Wednesday evenings for many years talking about older radios. I happen to be on a Central Electronics 10A from the year 1952. I always like to say that this radio went on the air when General Eisenhower was figuring on being president someday. It is paired up with a Drake R4 receiver by way of a transceive adapter that I built and demonstrated at one of our previous vintage radio meetings in Jonesboro, Tennessee.
One on the right.
The 10A drives a converted night kit 50-watt CW transmitter to about 40 watts, and that's going into a Drake L4B. Anyway, we're going to talk about vintage stuff here today. Buy, sell, trades are welcome if they're boat anchor related. If you have a technical question about a radio you're working on, this is a good place.
Now, we'll move on to the next one. I hope.
Okay. All right. Well, this is K5LYN, Lynn in Austin, and I have shifted gears here. This station started out its life in 1948 when Collins released their first permeability tuned oscillator VFO to be the exciter for their various AM rigs of that time period. This is a 310B, and I'm using it to be the VFO for Heathkit's 1959 single sideband adapter, which they called the SB10. And this was a little gimmick that they sold that you could match up with your Johnson Viking Ranger or your Valiant or your Viking 2 or your Heathkit DX100 or your Heathkit Apache or your Collins AM rig or your Homebrew AM rig, and make it talk a primitive kind of single sideband. I used it to convert the Heathkit DX60 novice rig over to single sideband, which is putting out about 45, 50 watts maybe. And I'm using that now to drive the same Collins 30L1 that I was on a while ago. So you'll probably notice it doesn't have great sideband suppression. It doesn't have great carrier suppression, but that's the way it was in Heathkit's first attempt to build a single sideband transmitter. All right, let's see. Who else is out there who wants to talk boat anchors tonight? And by the way, AXW, Bill, your National NCX3 sounded really good. Who else for the boat anchors? K5LYN, calling and listening.
We're halfway through.
Off and give it to Jay. Jay can give it to Rusty, and then we'll go around the table again. And I'm going to operate 2 different radios tonight. At the moment, I'm on a cheap and easy SSB homebrew transmitter built by KG7TR, based on 1956 QST article by the same name, cheap and easy SSB. But KG7TR Mike, who may come by and talk to us in a minute, is an expert and an artisan who has added some upgrades to this 1956 circuitry, and folks usually think it works pretty well. Okay, I'm going to talk to TXW, DPP, DR, IE, MOK, and then I guess I'll give it to Jay after that. So my neighbor, Mr. TXW, what do you say, George? K5LYN.
Net guys, you got yours lined up
Previous
there?
net control transmitter.
Well, let's see. Am I on the air? Is my speech intelligible? K5LYN.
Oh yeah.
All right, well, I'll do it. Okay, this is K5LYN. My name's Lynn, and this is a Central Electronics 20A, a very early single sideband exciter from about the year 1957. And it's driving homebrew amplifier 46DQ5s, and instead of the outboard VFO that the 20As required, I'm using the VFO in my receiver, the SX115, so that the station transceives. and that makes it kind of unique considering it was a mid-50s kind of configuration. All right, I think there was one other fella in there. What about EDX? We didn't pick up Byron, did we? EDX, Byron, did we talk?
Is it happy hour time? I'm done. Thanks for coming.
Thank you very much for coming today. I really appreciate you all being here. Yes, sir. It's the vintage, well, they call it the...
Well, 20 meters, 14,290, 2.5 Sunday afternoons at 2 o'clock, 1 o'clock Central Time. For this is 80 meters, 3870
Yeah,
every Wednesday evening.
Right, it's called the Boat Anchors Unlimited Net, which means if you got any boat anchor, show up. In fact, we've had a few guys have checked in on AM and fooled us. They zero beat it so closely it sounded just like a regular single sideband signal until somebody said, "Man, you've got a lot of carrier." Yeah, but anyway, thanks a lot, guys, and I guess we'll see you all tomorrow in the flea market, right? Good. Y'all take care. Thanks again.